Traction-related issues in Little Cottonwood Canyon. Utah's mountain highways, particularly Parley's Canyon, I-80, Big Cottonwood Canyon, SR 190, and Little Cottonwood Canyon, SR 210, experience significant snowfall in winter. Many vehicles, especially commercial trucks, are unprepared and fail to install chains or traction devices. This leads to frequent traction-related incidents, including disabled vehicles, safety hazards, and traffic delays, all of which impede snowplow operations and reduce the reliability of the highway system. Problem: poorly designed chain-up locations. Insufficient locations. Existing chain-up areas are limited in number and may not be strategically placed where traction issues most commonly arise, e.g., before steep sections. Size and visibility. Many chain-up areas are too small to accommodate multiple vehicles or are not clearly visible to drivers, especially in low visibility conditions, for example, during snowstorms. Access issues. Steep ramps and tight shoulders make it difficult for large trucks to safely enter or exit chain-up areas. This discourages compliance and increases the risk of accidents. Inadequate shoulder space, but on opposite side. Practices in other states dedicated paved pullouts with ample length. Instead of relying on standard shoulders, states like Colorado, CDOT, and Washington, WSDOT, build dedicated, extra-wide pullouts specifically for chaining up. These are long enough to accommodate multiple semi-trucks and are located before the steepest grades or most hazardous sections. Concrete pads with lighting. Oregon, ODOT, has installed specialized chain-up areas featuring concrete pads, which shed snow and ice better than asphalt and high-intensity lighting. This greatly improves safety for drivers working on the ground at night and in poor weather. Proposed improvement: expand existing chain-up areas, widen and lengthen pullouts, modify existing sites to accommodate more vehicles, especially large trucks, reducing overflow onto the travel lanes. Improve grading and drainage. Ensure chain-up areas are as level as possible and have effective drainage to prevent ice buildup, making them safer and more usable. Install high-intensity lighting. Illuminate key chain-up areas to improve safety for drivers installing chains at night and in storm conditions. Develop new, strategically located sites. Identify last chance locations. Place new chain-up areas immediately before the steepest grades and most high-risk sections where traction is absolutely mandatory, e.g., before the final climb to Alta and Snowbird in LCC. Create chain-off areas. Provide safe, designated areas on the downhill side for drivers to remove their chains, preventing them from stopping on steep downgrades where they can lose control. My proposal is to construct a new, high-capacity, enforced chain-up area on the large, flat lot on the north side of the intersection of Wasatch Boulevard and SR 210 before the canyon entrance gate. This location is upstream of the canyon mouth. It intercepts non-compliant vehicles before they enter the steep, high-risk section of SR 210. This is a proactive, rather than reactive, approach. It prevents disabled vehicles from ever blocking the travel lane. Geometry: the existing chain-up area is on a curve and a grade. The proposed site is on a large, flat parcel of land. This makes it dramatically safer for drivers to install chains and for large vehicles to maneuver. Available space: the lot is expansive, allowing for a configuration that can accommodate 20 to 30 trucks and numerous passenger vehicles simultaneously. This solves the critical capacity issue of the current shoulder-based area, which causes spillover congestion. Optimal visibility and access. The site is highly visible from both directions of Wasatch Boulevard and is the last major, easily accessible area before the canyon climb begins. This natural decision point is ideal for directing traffic. Enforcement feasibility. The geometry and space allow for the establishment of a seasonal compliance checkpoint. Enforcement personnel can operate safely off the main travel lanes, visually verifying chain requirements and directing non-compliant vehicles into the lot without causing traffic backups. This solution directly addresses the core infrastructure failure of the current system. Assumes a 2-acre lot. Based on UDOT and national averages, site preparation and asphalt paving can cost $400,000 to $600,000 per acre for a project of this nature. Lighting and electrical. Installation of 6 to 8 high-mast, shielded LED light poles with electrical conduit and connections. $150,000 signage, static and VMS, static signs, fabrication and installation of 5 to 10 new ground-mounted signs. $300,000 to $400,000 standard 15% of construction costs for design, project management, and unforeseen issues. 15% of approximately $1.25 million.